This is an area of mathematics that many students initially have a lot of trouble with, and I'd like to try and simplify it as much as possible and blow the myths out of the water. Algebra is all about patterns. There are patterns all over mathematics, and the algebra is a way of representing those patterns. Let's just start by an example. If we want to work out speed, there are three elements. There's speed, there's distance, and then time. If we divide the distance by the time, that will give us the speed. So distance divided by time is speed. That's the pattern. That's the, if you like, we call that a formula for calculating speed. Measure the distance, measure the time, divide the two, and we'll get the speed. Now that can be shortened to speed equals distance over time. That tells us the pattern that when we measure the distance, divide by the time it takes to cover that distance, and we'll get the speed. That's what I mean by patterns. If we wanted all multiples of 3, how could we write all multiples of 3? That's a mouthful just saying it, but what's the pattern that gives us, the algebraic pattern that gives us all multiples of 3? If we think of 3n, and n is positive integer, (3n) will generate all the multiples of 3. N's a positive integer. The first positive integer is 1, 2, 3, 4, 5, 6. So all multiples of 3 we can write as 3n, bearing in mind that n is a positive integer. If we let n equals 1, 3n is equal to 3 multiplied by n. It's not substituting a value there and then it's, so these are all the 30s. No, that's not what 3n means. So 3n understood between that 3 and that n is a multiplication. And if you've got n equals 1, 3n is 3 multiplied by 1 is 3, n equals 2, 3 multiplied by 2 is 6, n equals 3, 3 multiplied by 3 is 9, and so on. And you continue the pattern. All of those are multiples of 3. Multiples of 3 are all divisible by 3. So that's a powerful way to represent the pattern of all multiples of 3. This is a formula or an equation. An equation's another way, algebraically, we can express a pattern. You've already seen with Pythagoras that if c is the length of the hypotenuse and we've got a and b, that c squared equals a squared plus b squared, which is Pythagoras' theorem. That's algebraically a pattern. It says get the length of one of the sides, not the hypotenuse, and square it. Then we add the square of the other side, b squared. That will give us the square of the hypotenuse, or the longer side, c squared. That's the algebraic way of writing Pythagoras' theorem. So when we think of algebra, I want you to think of algebra as a way of describing patterns in mathematics. Whether it be a formula or a pattern in numbers, it just is a nice, neat, succinct way of writing that pattern.